What's up, guys? Mr. Antonucci here, coming at you with another video about square roots. And in this one, I want to talk about how to rationalize the denominator. So check this out. Sometimes you'll be asked to simplify a problem similar to this one, where it's square root of 4/7. Now, there's three things you need to keep in mind when simplifying radical expressions. Three checks that you got to do. Number one, you can't have any perfect square factors underneath the radical. The 4 in there breaks that rule. Second, you can't have any fractions inside the radical. This one also breaks that. The third one is that you can't have any radicals in the denominator if your expression has a denominator. So let's get started here. We already know this breaks two rules. There's a perfect square factor in there, and there is a fraction in the radical. First thing we'd want to definitely do is break this up using the quotient property into the quotient of square roots. And then we could take care of that perfect square factor of 4. Square root of 4 is 2 over square root of 7. Now, this still is breaking the rule that you can't have any radicals in the denominator now. We took care of the fraction in the radical and the perfect square factor in a radical, but now we have a radical in the denominator. And this is where we do what's called rationalizing the denominator. What we do is we multiply by an expression equivalent to 1 that gets rid of the square root. And how you do that is you multiply by square root of 7 over itself. So square root of 7 over square root of 7. Now what this does is it gives you a square root 49 in the denominator, because the product property, remember, multiply fractions straight across. So the product property in the denominator, square root 7 times square root 7, you can multiply the 7s inside and get square root 49. The numerator is just 2 square roots of 7. You cannot multiply the 2 and 7 in the numerator to get 14 because the 2 is not in the radical. So all you can do is multiply the 2 outside. Okay, now you would get 2 square root 7 over 7, and you're done. There's no rules broken here. There's no fractions in the radical. There's no perfect square factors in the radical, and there's no radicals in the denominator anymore. So we're done, and you go boom, mic drop. Okay, now another thing I see students do is they'll cancel the 7s. You cannot do that because the 7 in the numerator is not really 7, it's square root of 7. Okay, which is between 2 and 3. All right, so you can't just cancel those 7s out. All right, if we did another one, let's say you had 3 over the square root of, let's say 12. Okay, actually, let me clear some stuff off here. If you had 3 over the square root of 12, okay, first thing I would do is I know 12 has a perfect square factor of 4. So I'd write it as square root 4 times 3. And then the square root of 4 is 2. The square root of 3 stays inside. So I took care of the perfect square factor. What I do now is I still have a radical in the denominator. So I'd multiply by square root 3 over square root 3. So basically, whatever square root is in the denominator that's causing the problem, you multiply by that over itself. And you're allowed to do this because square root of 3 over square root of 3 is essentially equal to 1. So you're not changing the value of the problem, you're just rewriting it equivalently, kind of like how 1/2 is the same thing as 2/4. Okay, so you'd have 3 square root 3 over 2 square root of 9, which is going to be 3 square root 3 over 2 times 3. All right, now these 3's can cancel. I know the denominator would become 6, but you want to simplify. The 3's cross cancel, and you get square root of 3 over 2. Now, you might be thinking like, okay, why on earth would I do this? Well, when you get to trig, or even sometimes in geometry, when you do this, the values of trig functions, sometimes you end up with radicals like this that need to be rationalized. Okay, so there is one more kind of expression where it will like break the rule for the radical in the denominator. And it's a situation like this, where you have an addition or subtraction problem in the denominator that involves a square root. Before we get to this, I want to show you a property of binomials. Remember, binomials are expressions that have two terms. So a minus b and a plus b. These are called conjugates because they're the same two terms, except one is being added and one is being subtracted. If we FOIL these, all right, the firsts give you a squared, the outers give you plus ab, the inners give you minus ab, and the lasts give you minus b squared. Notice that the outers and the inners cancel. This is always going to happen when you're multiplying conjugates. If you have the same two terms, but one's adding and one's subtracting, when you FOIL them, the outers and the inners are always going to cancel, and you'll get the first term squared minus the last term squared. You see that? So we use this property of conjugates to simplify a radical expression that has addition or subtraction in the denominator. You can also do it in the numerator, but here the problem is in the denominator. You have a radical in the denominator that we need to rationalize. So let me recopy the problem here. Okay, and now the conjugate, all you do is take the two terms, the square root 3 and 7, and change the sign in between. So I would multiply by square root of 3 plus 7 over square root of 3 plus 7. Notice again, square root of 3 plus 7 over itself is essentially equal to 1. So we're multiplying by something equal to 1, so we're not changing the value, we're just rewriting it. Same way as whenever you added and subtracted fractions, you had to get a common denominator. And so you might have had to change 1/2 into 3/6 or 7/14. It's the same value, you're just expressing it in a different way. Okay, so now here's what we do. You distribute the numerator, so the 2 goes to the square root 3 and the 7, and you would get 2 square root 3 plus 14. The denominator, you'd FOIL it out, because really it's square root 3 minus 7 times square root 3 plus 7. And if you FOIL this, remember the firsts will give you square root 3 times square root 3, which is square root 9. The outer would give you 7 square root of 3. The inners will give you minus 7 square root of 3, and those will cancel each other out. And then when you do the lasts, you would have negative 7 times negative 7, which is, or excuse me, negative 7 times positive 7, which is negative 49. Okay, notice you still have a square root, but it's the square root of 9, which ends up being 3. So be careful here. 2 square roots of 3 plus 14 over 3 minus 49. Now, one thing I'll see students do sometimes is they'll try to cancel these 3's or reduce the 14 and the 49. You can only do that when you have just multiplication in the numerator and denominator. Since it's separated by addition and subtraction, you can't like cross cancel things over addition and subtraction in a fraction, and it has to do with order of operations. But what we can do is do 3 minus 49, and you would get 2 square root of 3 plus 14 over negative 46. And that, ladies and gentlemen, is going to be the answer to our problem, because we haven't broken any rules. We don't have any perfect squares in the radical. We don't have any fractions in the radical, and we don't have any radicals in the denominator. All right, so that's it for rationalizing the denominator. So you math ninjas out there and you mathletes, hope these mathnastics helped you out today. And if you have a problem that you'd like me to make a video about, drop it in the comments below and maybe I'll make a video about it. Don't forget to subscribe to the channel and hit the bell for notifications so that you know when new videos come out. All right, guys, that's it. Mr. Antonucci out.